Hello, everyone, and a very warm welcome to Directions Live Online. My name is Mary Murphy, and I will be your host for today's session. So today, you've joined us to explore GIS for the built environment and how to transform your AEC workflows with GIS. And joining us today to walk us through how we can leverage GIS and geospatial technologies to transform these workflows are Xinhui and Kai-Ying. Now, Xinhui is a solution consultant for the built environment with Esri Singapore, and her interests and expertise lie in the fields of urban planning and GIS. And she has years of experience with Singapore's Urban Planning Authority. So we're in great hands here today with someone who really understands the needs and the challenges facing those in the architecture, engineering, and construction, or AEC sector. Now, Kai-Ying is also a solution consultant for the built environment with Esri Singapore, and she too has a background in urban planning and GIS. And having worked with urban design and planning in Boston, she's now back in Singapore designing solutions for the built environment and transportation. I would like to say a lovely warm welcome to both of our speakers. It's great to have both of you here today. How are you?
Hi, Mary. Glad to be here.
Happy to be here.
Excellent. Okay, that's enough of that. So now that the introductions are out of the way, I'm going to leave you in Kai-Ying's very capable hands. Over to you, Kai-Ying.
Thanks, Mary, and welcome everyone. So today you've joined us to explore how to transform your AEC workflows with GIS. For today's session, we will give an overview of the technology trends that we're seeing relating to architecture, engineering, and construction, and how GIS can help to enable organizations to keep up with those trends. We will then dive into the A, E, and C of AEC. Here we are defining it as architecture, urban design and planning, engineering and consulting, and construction management. And our goal today is to share the capabilities of how GIS can add value to your work. We will also have a fun little activity in the last section before we wrap up with some sharing of some resources. So let's get started with technology trends in the built environment. These may not be all of the trends, but we want to highlight these as they are relevant to location intelligence. First, automation in design. We are anticipating an increased prevalence of design automation driven by data. Greater efficiency can be achieved in the design process as automation is poised to play a crucial role in role-based design analyses. Second is automation in execution. Automation will also significantly impact manufacturing and construction procedures. Escalating adoption and utilization of prefabrications will accelerate the integration of digital machinery within the construction sector. Third, projects are becoming more data-centric. AEC is shifting from project management focused on solutions to a data-centric approach, utilizing sophisticated tools and platforms that enable the sharing and analysis of 2D drawings, 3D models, and non-graphical documentation. And lastly, real-time or Internet of Things. In 2023, an increasingly prominent concept is connected BIM, which empowers users to establish data connections throughout the entire lifespan of a building or asset. The utilization of a digital twin is one method to achieve this, facilitating the optimization of outcomes through insights derived from previous projects. So for designers, connected BIM offers the opportunity to enhance both the transmission and integrity of information while also enabling the integration of diverse solutions. Taking a look locally here in Singapore, how are these trends emerging? So one framework that is supported and encouraged by BCA is Integrated Digital Delivery, or IDD. IDD is a framework to digitalize the whole construction workflow such that a single piece of data flows through from design to delivery, BIM being one of the key foundations to enable the whole IDD process. And to keep up with these trends, government agencies are also leveraging GIS. For example, URA Space, which is an online web app, allows users to display planning requirements for individual sites and query site-specific data. Additionally, CoordinateX is also moving towards submission of building models that are geo-referenced based on location-specific requirements. And I believe CoordinateX will be soft launching by the end of this year. So considering how to incorporate and leverage GIS into your work now is in line with how government agencies are moving forward with their submission requirements. As we can see from the industry trends, location data and location intelligence has become a powerful driver for the work done by the AEC industry, and that brings us to GIS. Some of you may already be familiar with what GIS is, but just to make sure we are all on the same page here, GIS, or Geographic Information Systems, is a system that enables us to create, manage, analyze, and map data. It integrates location data, so where things are, with what things are, and is used to answer all sorts of questions across industries. ArcGIS provides tools to do just that. ArcGIS is a comprehensive geospatial system that provides the capability to first set up a geospatial infrastructure for an organization, to manage data efficiently, to take that data and apply location-based analytics and gain insights on your business practices. Lastly, you can take those insights and visualize them in an accessible way for stakeholders and non-GIS users to use. And the final trend is the emergence of AEC, the architecture, engineering, and construction industry. We will use this term throughout this session, so moving forward, how can GIS transform our built environment or AEC workflows? Let's take a look at just that, how GIS, in this case ArcGIS, can transform our AEC workflows. Let's start with the building lifecycle. From planning and design to construction and operations and maintenance, integrated digital delivery can also be overlaid on this. For example, digital design would influence master planning and design, while digital fabrication aligns with pre-construction. The key takeaway here is that no one task here is done in isolation, and they are all connected. And one of the few constants is location. Location is what connects data that might seem disparate or unlinked. And it is through the use of location or inclusion of the geographic approach as a part of a digital framework that leads to successful, informed, safer, and enabled decisions. By being GIS enabled, we can apply these patterns of use to your work, starting with mapping and visualizing data to understand location and relationships, very much what you would do for site context, suitability, or feasibility analysis. Field mobility allows you to more efficiently collect site inspection data and share it with staff back in the office. Or perhaps you want to monitor assets in near real time and make sure all that data is managed in an organized and centralized location. By using GIS for design and planning, designs are more quickly informed with context data, and alternative design options can be easily shared and collaborated on using ArcGIS technology. So by leveraging location intelligence, such as GIS and BIM integration, mobile tracking, and on-demand 3D-based maps, AEC activities can be supported in a more informed and efficient manner. The next three sections, which you see here, we will show examples of how to leverage location intelligence for these three components within AEC. Let's start with GIS in architecture, urban design, and planning. Here we see an overview of the architecture, urban design, and planning workflow. I won't go into detail for each step, but some of the challenges faced in this workflow include where to find 3D data to quickly create site context, bridging analytics with design revisions and the time and cost associated with that, effective communication to encourage community engagement and collaboration, and lastly, to assess different scenarios or designs quickly. And GIS can help us tackle and resolve these challenges. It can support the quick creation of 3D context, including buildings and terrain. GIS can also support site analysis, so it can spatialize patterns and insight to better understand the site and support decision-making. GIS can be used for designing street circulation, subdividing blocks, linking building regulations and policies with what is being proposed, and the quick development of massing studies. Further, it can support scenario comparison and the assessment of each scenario's metric outputs and impact. And GIS can also be used for stakeholder and community engagement, for communicating a project and its different phases, collecting community feedback on different proposals, and more. Let's now take a look at some examples of GIS in action. So first off, GIS for site context. Planners and urban designers need a way to get site mapping detail quickly. Within one of our desktop products called City Engine, you can use the get map data function from OpenStreetMap data to get project site context. Once an area of interest is selected, you can set and select what type of streets and 3D buildings for that area you want to import into the scene. So for example, you can omit pedestrian paths and trails, as well as many other useful parameters. And here we see on the screen that now we have a decent LOD1 urban data model to begin work with. We even have 3D base maps available on our web platform. And this is once again using buildings from OpenStreetMap. It's as simple as selecting the 3D base map theme that you want and watch the 3D buildings fill in. You can also apply a 3D mask for a project site by drawing a polygon around it. This is showing the buildings on the site removed, but you can easily flip it so that surrounding buildings are removed and only your project site buildings are shown. In just a few clicks, you have a decent LOD1 model available for site context. Jumping into scenario planning for our map data, here we have 3 scenarios that we can use to highlight some key metrics from a configurable dashboard. And the dashboard will pop up on the right side, where we can then choose, for example, jobs from building space designated as office. We can view the 3 scenarios side by side and edit as needed for the desired outcome your team is trying to achieve. And of course, these models can be shared in multiple data formats or published to the web to share as well. As designers, we do a lot of work in software that is on our desktop or publish plans and designs in a static PDF that is hundreds of pages long. In the last few years, this concept of interactive storytelling has become quite popular to convey and communicate plans and designs to the public. Because it's on the web and is interactive, you can see here on the map, it's also much more interesting for stakeholders to go through. There are multiple ways to visualize numerous scenarios or designs. You can configure it to highlight specific areas, but my favorite is to use the map swipe widget to illustrate a before and after scenario. So those were a few examples of how GIS supports the A in AEC, but now let's transition to how GIS can add efficiencies for engineering and consulting. When it comes to engineering and consulting, some of the main focus areas for GIS to enhance existing workflows include field site inspections, such as digitizing forms so site inspections can be done on mobile. That data is then synced with a dashboard that displays the data back in the office. Shinhui will focus on field and site inspections later with mobile apps, so I won't dive into it here. But feasibility studies, which include mapping out site context layers such as slope, floodplains, and transportation data, but we don't have time to cover GIS for feasibility studies today, so perhaps we'll schedule another webinar to take a look at this. But what I'll be focusing on demonstrating today is BIM to GIS data integration, where you can take BIM CAD data in different formats and access them in the ArcGIS environment, both on desktop software and on the web, where stakeholders can access designs and relevant data. You can even access map data in your organization's ArcGIS cloud from within Autodesk apps. Currently, data exchange gaps create waste and duplicate efforts. As a result, there has been increasing demand for BIM and GIS interoperability. Based on the 2022 Geospatial World Study regarding the efficiency and benefits of GIS and BIM integration, they found that there is a return on investment. On average, GIS and BIM integration saved 28% of the time spent on the design phase, 90 days for construction, and 13% of cost savings. This process of BIM and GIS integration and interoperability reduces data silos and informs efficient decision-making through all parts of an asset lifecycle. To realize these time and cost savings, AC firms, operations, and agencies need support to integrate GIS with existing BIM or CAD workflows. Here's an overview of how the ArcGIS system integrates with CAD and BIM, from direct read capability to built-in database connectors. For example, being able to consume a wide variety of CAD and BIM datasets in ArcGIS Pro. Or even, there are multiple tools for accessing GIS services from within Autodesk desktop applications. like the Autodesk connectors and Esri's ArcGIS for AutoCAD plugin. Let's take a look at some ways we can integrate BIM and GIS. BIM and CAD data can be integrated into our GIS desktop software, ArcGIS Pro. Within Civil 3D here, we have some data for a massive highway interchange that includes bridges. We can bring that data into ArcGIS Pro. Here you see 22 BIM models, and it can include quite a number of details such as attributes, alignments, corridors, noise barriers, and even lane markings. You can bring in other GIS layers like proposed topography as well. Once you've brought in your BIM data into ArcGIS Pro, you can then publish that information to the web where stakeholders who might not have GIS experience or the desktop software can also access the designs. You can make it easy for them to navigate by setting up specific camera angles to toggle between. Some of you may prefer to utilize the GIS data in Autodesk itself, since that may be where your workflow lives. To accommodate that, we have a partnership with Autodesk and have plugins available that allow you to access your ArcGIS organization's data and even sync edits. First, you have to sign in with your ArcGIS license. Then you would want to search for content you want to add to your project. So in this case, we are adding gas utility lines, and here we're searching for tree points. And once we add that to our project, we'll see that the white lines are loaded, and those are the underground gas lines, and the white dots are the trees. But what if you did a site inspection and saw that there was a tree missing? When you're on site, you can use a mobile app to collect the point data. There are different asset categories. Select the type of point you want to place, and then fill out the attributes, and then hit submit. The data is then synced and updated to the tree layer you've added to the CAD file. And once you've updated the data, you see that that added point is now in your CAD file. The same can be done if you're making edits in CAD and want to see it on GIS web app. You can edit the gas line here. Once again, take a few steps to make sure it syncs back to the GIS data in your organization's cloud. And then back on the GIS web app, you see that the line got extended. In addition to viewing BIM and CAD data on our desktop app and integrating GIS data into Autodesk apps, we also have a collaborative web application called ArcGIS GeoBIM. GeoBIM goes beyond just visualizing the data by helping stakeholders understand project status and insights through 3D maps and dashboards. GeoBIM allows you to open linked documents like DWGs, as you see on the right side, and view them in a fully functional 3D viewer to go through BIM models or drawings in the source BIM 360 project. So to wrap up this section, I hope you can see how the integration of BIM and GIS can reduce data exchange gaps and duplicate efforts by reducing data silos and inform efficient decision-making. I hope these demos have sparked some ideas on how your own workflow could benefit from this. So please feel free to drop any comments on how you would apply this in the chat. With that, I'll hand it over to Xinhui to bring us through GIS and construction management.
Thanks, Kai-Ying. So next, we'll dive right into the GIS in construction management. So far, what we have seen are mostly desktop applications of GIS. But in fact, GIS can also help to support mobile workflows too. And this is particularly applicable to the construction industry, where the bulk of the work happens outside in the field. GIS can support various field operation activities, from planning of work, navigating to assets, understanding your surrounding work site, capturing data, and monitoring real-time conditions. We will be exploring some example use cases for each of these over the next few slides. But before we do so, we would like to begin with a hands-on activity to simulate a defect inspection exercise. So imagine that you are part of a defect inspection team checking for defects along roads in Singapore. Traditionally, how this might be done would be that the defects might be noted down on paper forms or even stored digitally, but with an additional step of having to transfer the information over when you are back in the office. In addition, the location information might also not be captured accurately, and you may need to refer to physical markers, such as the lamppost numbers, in order to describe the location of defects. GIS can help to streamline this workflow for greater efficiency. Upon spotting a defect, workers can use their mobile devices to report the defect location as well as the other information. So let's try this together, and please scan the QR code on the screen in order to access the digital form. Yeah, you can allow it some time to load, and then you will see the form on the right. From the digital form, you can select a request type from the drop-down list. As for the location, you can either use your current location or you can pan to a random location on the map. You can add in some comments under the additional details section, and do also attach a photo of your surroundings if you can, for instance, your work desk or the view outside of your window, so that we can see them later. And don't worry, because this is purely a fictitious exercise, and whatever reports that you submit will not be reported to any authorities. After the reports are submitted, they will be summarized on a dashboard. For now, we will leave the QR code at the top right-hand corner of the remaining slides so that you can take your time to submit the reports, and we will run through the dashboard at the very end. Now, let's move on to the construction use cases proper. We've identified 5 key focus areas of the construction industry and how GIS can help in each of them. Firstly, to increase workforce productivity, GIS can be used to digitize forms to facilitate data collection from site, as simulated by our earlier activity. Assignment of job tasks can also be done easily, and notification of task assignments can be automatically sent to workers on site. Secondly, GIS can be applied to worker safety by allowing the tracking of worker locations on the dashboard. Geofences could also be set up for danger zones, and alerts can be sent if the workers enter the geofenced areas. Thirdly, construction companies manage multiple work sites at once and will need an overview of the projects in order to optimize assets and resource deployment. Dashboards can be built to monitor asset status and locations, as well as the key metrics of each construction project. Fourthly, project timeline is critical to a construction project as it impacts the bottom line. Various tools such as BIM and drone imagery can be used to monitor and track the construction progress and ensure that all stakeholders are updated about the latest site progress. And lastly, the real-time feed of IoT sensors can be set up so that managers can track the environmental metrics of a site, such as the temperature and air quality. Let's see that in action now. The screen shows a dashboard which was built to provide an overview of the various projects that is managed by a construction company. In this dashboard, a map takes the center stage and shows the location of all the work sites. To find out more information about individual work site, we can click on the work site on the map. The contract information, as well as the key information about site personnel and equipment, will then be displayed interactively. A dashboard can also be set up for an individual work site in order to track worker and equipment locations in real time. This can allow the site manager to know how many workers are on site for safety reasons. Geofences can also be set up for danger zones, for instance, around the heavy equipment. And alerts can also be sent to workers who are within these danger zones, and this is also displayed on the dashboard in red. This is another example of geofencing, this time from the site worker's point of view. The job site is demarcated by the blue polygon. So when the worker enters the job site, they will receive a notification that the location tracking has started. While the location tracking is on, the live location of the worker will be sent back to the office in real time. A danger zone is also demarcated, and this time by the red polygon. So when the worker enters into the danger zone, they are once again notified by an alert on their mobile device. This ensures that the workers have a greater awareness of their surroundings and do not accidentally venture into a dangerous area. Next, construction schedules can also be brought into a dashboard and visualized in an interactive manner. This example on screen shows the import of schedules from Oracle Primavera P6, but we can also import from other platforms as well. By linking the project schedule with spatial assets, the progress of works can be visualized on a map. BIM models of the approved buildings can also be uploaded and symbolized with different colors in order to represent the different stages of construction progress. In this example, blue means completed works, red means work in progress, and gray means pending works. Having this not only allows all stakeholders to be updated on the latest construction progress, but also be able to visualize the end outcome of the construction project. Other than BIM, drone imagery can also be brought in to show the progress of the worksite in 3D across the construction period. Here you can see that the construction site is flattened. And in the next drone capture, you can see how the buildings have already been erected and is mostly complete. With this drone imagery, measurements can be done based on the 3D scene, and this also provides a historical record of the site over time. Next, a construction work site has many environmental impacts on its surroundings, and many work sites also have sensors to monitor this. The data captured by IoT sensors, such as air quality sensors, temperature sensors, and so on, can be ingested by ArcGIS into a real-time dashboard. This means that environmental indicators of a site can be tracked in real time. This allows for better situational awareness and the ability to identify and respond to any anomalies quickly. Now that we have covered the other use cases, let us now go back to the defect inspection activity that we did earlier. All the reports that were submitted via mobile devices will be synchronized to the dashboard in real time. So now you can put yourselves in the shoes of a defect inspection team manager who is supervising the defect inspection works. First, let me just refresh this so that the latest submission can come through. Just give it some time to load. Okay, so you can see that at the table on the top, these are the reports that have been submitted. You can see that it's also been sorted according to the submission date with the latest submission on top. So if we click on any of these submission reports, the map will zoom to the area that the defect was reported from. And you can see the details. If you have typed anything, it will be here, the location as well. And if the submitter has submitted any photos, you can see the photos over here. Very nice photos of the damage curb. Yeah. You can see a few more examples. So here we see a report of illegal parking happening at Hillcrest Park. And then again, you can click to the photos. I see that some of you have Googled some images to upload. Yep. And then let's see one more, which is water over the road at Agnew Avenue. And then photos. Yes, very fitting photos over here. This is all well and good. You can see all the reports coming in real time and where it's located on the map. But if you were the supervisor, you would probably need something better, something more intuitive to use where all the statistics are being summarized for you. So this is where all the information would now be summarized into a dashboard. On this dashboard, the map takes the center stage again, with all the reports being shown on it. And the reports are now summarized on the right side. So we can see that there are a total of 87 reports submitted, again sorted in terms of the submission date with the latest one on top. So if we click on any of these reports, once again, the map will zoom to the area and you will see that the information over here alongside any photos. Yeah, very nice park. So what the supervisor is likely going to do also is to want to sort the request by the type. So for instance, if he's prioritizing the pothole inspections, he will click on potholes. And now the map will filter down to only show the potholes that are reported. And immediately from the map, he can see the spatial distribution of these defects. And on the right, the pothole requests have been filtered out as well. And there are 20 of them. Other than by request type, you can also do so by the month of submission. So if we were to focus on just November submissions, we can again click on it and see the spatial distribution and also see that the reports have filtered down on the right. He can also do some cross filtering, whereby he wants to know damaged curb or gutter in the month of November. And then he can do so, and again, all this will filter through interactively while he is using the dashboard. So the dashboard is very flexible, and the supervisor with this can have a good overview of all the defects that are reported from various locations in real time. Yeah, now let us go back to our slides and wrap up some of the key takeaways from today's session. So this is a diagram that we saw earlier, and it summarizes where and how at each stage of the AEC workflow, GIS can bring value to the users. Firstly, we know that location plays an important role in AEC, so being able to map and visualize location of projects, assets, and people accurately and in a timely way is crucial. Secondly, through the hands-on activity, we have seen how the field mobility applications allow for mobile collection of data and streamlined workflows. Thirdly, we have showed how 2D and 3D spatial analytics can help to support decision-making in planning. In terms of design and planning, GIS can support comparison and evaluation of different planning scenarios. Fifth, the real-time dashboards and IoT sensors can also help in the monitoring of site situation, for example, for construction use cases. Sixth, in terms of the data management, GIS supports the end-to-end workflows, managing the dataset from the planning stage to the construction stage, and even after the building projects have been commissioned, to the operations and maintenance stages. And lastly, GIS is able to facilitate sharing and collaboration, as the information can be made easily accessible from a browser and does not require the installation of heavy software for the end users. So what we have managed to cover in this short webinar only scratches the surface, and there are a lot more resources out there where you can learn more about GIS and the AEC industry. We have compiled some of these resources in this slide, which you can access after the webinar via the recording.
Okay, so thank you again to Kai-Ying and Xinwei, and thanks to all of you for joining us. We loved having you. We will see you again soon for another Directions Live online webinar.